If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay students, let's welcome you all in lecture 10 of this GATE Engineering Mathematics Calculus series. Today we have taken again 3 questions, 21, 22, 23 questions on line integral and maxima minima questions. Okay, then let's start. Okay, what is in question number 21? In question number 21, the function y is equal to given is defined over an open interval this. At least one point in the interval dy dx is exactly. So y is given and an interval is given 1 to 2, and they are asked you to find in the interval at least somewhere you should find a value of dy dx. Okay, you can recall your secondary school mathematics. You have heard about these two theorem, Rolle's theorem and mean-value theorem, also known as Lagrange mean-value theorem. So the question is from there, because they have given some value, at least one. Whenever you heard this word, at least 1 point where dy dx, at least 1 point where dx, then you think that it is a question of Rolle or LMVT. Both are same theorem actually. The first is started from Rolle and then Lagrange mean-value theorem. They have just generalized it. So first let me write the formula for Rolle's theorem. Rolle told that if your fa is equal to fb, fx was a function, ab are 2 points. Suppose this is your x and y axis. The physical interpretation of any theorem is very important. Then only you can remember this one. If you can interpret it, they have given fa is equal to fb. These two lengths are same of the function. Whatever the function, I don't know, it can be a curve, straight line, anything between x and y if I draw. But at this point, this length are equal. So whatever graph you draw, whatever way you can draw, curve, whatever, so many zigzag ways you can draw, but you will find at least one point where it should be, this tangent should be flat to horizontal. Suppose if I take this way, then here you will find lots of, not one, more than once. So you will find at least one, because you have to go from here to here, and if you have to go from here to here, you have to take a turn. Once you have to take a turn, if you go straight also, then every point is flat. There are infinite points. And if you want to go minimum, so minimum you have to take at least one turn. If you are going down, then you have to come up, and there is a valley point, it will always reach. If you go up, then you have to come down, because you have to reach here. So you will find a point where it is flat. So Rolle says if any function where f equal to fb, then you will find at least a point between a and b, where f dash c, the differentiation will be 0. Where c is in between a and b. C lies in between a and b. You will find at least one point where f dash is equal to 0. Now what in main value theorem, what they have did, they have just generalized this Rolle. They have used a little bit more of their brain, and they have just generalized it, and then now they are saying it is not necessary that these two should be equal. fa cannot be equal to fb. These are not mandatory. If it is equal also, then also okay. If it is equal, then it will come to Rolle's theorem. So it is more general version of this one, and this is specific version of this one. If it is equal, not equal, they are not mentioning at all. It can be equal also. If it is equal, then it will go back to your Rolle. It can be this or this, whatever fa fb. Now you think, whatever way you go through this, you will find at least a point where your tangent will be parallel to this line. This is your line. You join a line AB. This is the simplest way you can go. If you go in this way, then every point is parallel to itself. Every point the slope will be parallel to itself. But if you want to take a curve, anywhere you take curve, then you have to move. You can think your x-axis now become like this. This is suppose your x-axis. So this is flat, suppose you can think. So you will find if you are going from here to here, you will find at least a point where it should be flat. If you are thinking x-axis in this way. Or you can generalize. You can go in so many ways. You can draw as number of ways you can draw. You try. And you will find at least one point where it should be the slope. Suppose this point, the slope is parallel to this line. So what is the slope of this line? This is height. This is what is this gap? B minus A, because this is B and this is A. This is f of A, this is f of B. So what is the height of this line? If I take this from here to here, this height. So slope of this line is fb minus fa. This is the change in height, fb minus fa. and this is the base change, b minus a. So this is the slope. So they told you will find at least one point where the slope is this. And what is the slope? Slope is dy by dx. That is f dash x. So they have given, so the formula becomes this. So you will find at least one point C, where C is in between, again A to B. At least one point dy dx which should satisfy this. So here the same question, at least one point you have to find where in between 1 and 2 where dy dx should be equal to something. So we know dy dx should be equal to something. So if you can check if it is f of 1, f of b is Rolle is specific, the answer will be 0 Rolle. At least one point you will get 0. Here at least one point you will get where the answer is equal to this slope. So this is more general question. If you can remember this, Rolle automatically will. If both are equal, then it will be 0, 0. When FB and FA are equal, numerator will be automatically 0. So if I put this one, so here f dash c, at least one point, that is dy dx, at least a point C will be equal to, what is your FB? FB is f of 1. So it is f of 1. Should I write? Okay. F of 2 minus f of 1 divided by 2 minus 1. Okay. If it is 2 minus 1, this 1. F of 2 is 5 into 4 plus 10 minus 5 plus 10. 30 minus 15. Oh, it is 10x, I think. Oh, sorry. It was 10x. 5x square plus 10x. So 10 into 2. So 20, 20, 40 minus 15. Answer is 25. That is B. Okay, then next is 22. 22 is... so always you try to understand the geometrical meaning of the theory, then theorem. Then you can easily remember it. That will be helpful. I always recommend that. 22. 22 is the line integral of the function f is equal to yzi in the counterclockwise direction along the circle. So you have to, this is the path. Path is very important. We want to draw the path. Every time we will draw the path and we will parameterize the path. So it is a circle, you have to go in counterclockwise direction. Remember the direction I told you every time. At z equal to 1. So your z is equal to 1 they have given. So your function easily becomes f is equal to yi cap. Because z is 1 they have given. That is good. So what is the equation of the path? X square plus y square equal to 1. So what is our first job? Is to parameterize this. How will parameterize this? It is a circle. So for circle it is x equal to r cos theta. R is here 1. So x is equal to cos theta. Y is equal to r sin theta. That is sin theta. So you need to find, you remember the formula of line integral, na? F dot dr is t a to b. Again you can check if you forgot the earlier videos where I have mentioned you. This will come from parameterization and dot r dash t. So what is your r dash t? This dash, this dash. Cos dash is minus sin theta I cap. Sin theta is cos theta j cap. So if you take dot product of these two, then you will get the answer as, this is your yi. So yi will be there. Only limit I will put and dt. So here it is theta. So it will be d theta. And dot if you do, then it will be y into minus sin theta. So y is what? Y is your sin theta. So this y is sin theta. Sin theta I cap dot minus sin theta I cap. So minus sin theta. So you will get, and the limit is, because you want to make it a full rotation, counterclockwise direction along the circle. So it is 0 to 2 pi. You want to move along the circle in counter. So 0 to 2 pi. So minus sin square theta. So sin square theta you can write 1 minus cos 2 theta by 2 d theta. So minus half you can take common, then it is theta minus sin 2 theta by 2, 0 to 2 pi. If you put, then it is minus half. If you put, it will be 2 pi. Sin 4 pi is 0, sin 0 is 0, 2 pi minus 0, so it will be 2. So it will be minus pi. So minus pi is in option B. Okay, then next 23. 23 is fx is equal to the maximum value of the function in the interval. Here you check the interval is not a closed interval. This is an open interval. 0 to infinity. These are known as open interval. Along with infinity it is always open, but here 0 is also open, means x cannot be 0. So you have to think on that. So if it is x, I have told you in earlier class, for if there is a interval given, you always check the boundary point, but here you cannot check because x cannot be 0, x cannot be infinity, so we cannot put there. So the way to get maximum here is, the normal we will do, then we will also check the boundary points. That's what in the last lecture 8 I think I have told you in question number 9 I guess, or 7. 20 in question number 20, lecture 9. You can check that out. So if you differentiate it, x minus e to the power minus x plus e to the power minus x. So if you take e to the power minus x common, then it is 1 minus x. If you make it 0, then we are getting x equal to 1. Okay, if this is done, then what is they asked? Now which one is maxima, which one is minima? For that you have to again differentiate it. So if you differentiate this one again, x minus it will be plus. If I take differentiation, then it minus e to the power minus x minus e to the power minus x. If you put x equal to 1 there, then e to the power minus 1 minus e to the power minus 1 minus e to the power minus 1. So it is negative. So what it is negative means, it indicates that this is maximum point. But you always check whether they are asking point or value, they are asking value. So maximum value, you will put it in the function f1. So 1 into e to the power minus 1, so e to the power minus 1 or 1 by e. I think e to the power minus 1 is option A. So here checking in boundary point is not necessary because your boundary is not a closed interval, it is an open interval, it cannot be 0. So you cannot check at 0, you cannot check at infinity. If it is a closed interval, then you have to check these 2 points also. If one point is less than this, I have drawn some graph in the that question itself. In the 20th number question, you can check whether check those question, that question 20 number, where I have checked the boundary points also. Okay, then that's all for today. We will continue in next lecture. If you like the video, then press the like button and please give your valuable comments in the comment section.